Good evening, friends. Welcome to ESAN Academy. As a part of embedded system programming, we are discussing about digital electronics and session 2. And you'll be very surprised. This looks to be very familiar name to you, but you may not know that one information. This is a one logic, that is combinational logic, which connects your hardware and software. You'll be very surprised the moment you know that. And this is one of the most easiest in the electronics. One of the most easiest logic is this, but it does miracle. So please understand this. Maybe just because of easy. Normally we have a tendency. We always give a lot of priority for learning the tough things. We don't give priority for learning the easy things. But so industry is ulta. Industry respects people, those who know the easy things and better. And the trick here is, because everybody knows very easy, you have to be a master of that. That's a trick. That trick, we will practice that in the coming days. Be with me as much as time till you master it. I'll tell you that when you master. Please, that's not a joke. It's a very important one. We are not being trained in the schools and colleges everywhere to master what you know. We spend all the time to study what we don't know. No, that's not the thing we wanted. Here is different altogether. So we start from very simple. One of the things we all know that. We all know that what is that, but we never give a much priority. We assume that we have a human being. Let's say my name is Balaji. Somebody's name is James. Somebody's name is Salim. Assuming I have 3 people. Now, if somebody calls by name, we all will listen. If somebody calls Balaji, he also listened to Balaji. He also listened to Balaji. And I also listened to Balaji. But I will say yes. This guy will say no. Which we know very clearly. Every day we do that. Every human being is having a name. Now, I ask you another question. Who gave you the name? Who gave you the name? Can you guess? It's a very tricky question. Who gave you the name? Your parents. Your parents gave you the name. Am I right? Next thing is, how do they create the name? How do they create the name? From the alphabets. Let's take English. So A to Z, you have 26 alphabets. From the 26 alphabets, they put so many combinations. Whatever combinations they like. It's because this is their product. Nobody can give a name except the parents. So they like the combination. They gave me Balaji, they gave me James, they gave me Salim. They gave me Raju, they gave me Balu, whatever it is. You understand now? So, a name is nothing but, what is name? A name is nothing but combination of alphabets. Do you agree this? If you don't agree, let me know. I say that a name is nothing but combination of alphabets. Do you agree this? This is the start of a session. So better understand what is name. You can build any number of names. Yeah, that's as simple as that. A name is nothing but combination of alphabets. Now, let us go to the world. We go to the new world. In that world, there is no alphabets. In that world, there is no alphabets. They have only numbers. 0 to 9. So This guy name will be 1256. This guy name will be 735. This guy name will be 125793. Am I right? Like instead of having a name called Balaji, Raju, James, this other world where there is no alphabets. So they call this as a combination of numbers. Here is a problem came. There are two types of world. In one world, we use decimal. There is another world, they use binary, 0 and 1. So we call this as a combination of decimal numbers. Now we go to this world where only 0 and 1 are there. So his name will be 1001. His name will be 0110. This guy name will be 111101. Because only 0 and 1 are there. So the names are used only 0 or 1, no other thing. Like you have a name alphabets A to Z. You don't call your name as a dollar. Yeah, sorry. Nobody give you a name like this. B dollar A hash. Am I right? Your name that you cannot pronounce. That's why they call you Balaji, James, everything. So I have three type of names. One is first name is combination of alphabets. That is Balaji. Next one is combination of what? Decimal numbers. That's called 1895. The third one is combination of binary numbers. Zero, one, sorry, 10, 110. Am I right? So that's a three-way. Since we are working on digital electronics, which is 0 and 1, I am not worried about this. I worried about only combination of binary numbers. Now, forget about this. They have a block. The blocks are having a names called. This block is having a name called 10110. This block is having 0010, 111110, whatever it is. But unfortunately, binary numbers are having 0 and 1. Sometimes it is called yes, no. Sometimes it's called on, off. Glow, not glow. Success, failure. True or false. So they call this as a, instead of calling this a binary number, they call it a combination of logic. The true or false is the logic. That's the way it started. They call logic. That's why they call logic gates. See, the gates are called logic gates because the logic is nothing but true or false. It's not arithmetic. It's logical answers. And somehow they don't like combination of logic. So what they have done, they made this as a, this combination of logic has been changed to combinational logic. Understand now? The combination of logic has been changed into combinational logic, which is nothing but, please understand, combinational logic is nothing but a name of a block. It is a so combinational logic. Nothing but a binary name. You understand that? It's a binary name, nothing more than that. The combinational logic is nothing but binary name. Understand? This has to be very clear to you. If I give a block, that guy should have a name. The name could be even zero itself. Why not? Can give only one bit. So if you call him zero, he will say yes. Yes means zero, one. No means zero. The output also one or zero only. So same way, a name can be 00 or 100, anything. Sometime a name can be like this. I have a name can be 10110000111001. Like we have a name, Ananta Padmanabhan. Am I right? Ananta Padmanabhan Venkateshwaran is a big name. Also, we have a small name called Ram. Am I right? We call somebody G. Am I right? We have a 2-letter word, 3-letter word, 4-letter word names like that here. So please understand, a combinational logic is nothing but a name. That's it. A name, nothing more than that. Now, he has one output, yes or no. Yes means 1, no means 0. You call me as a name. If you call me 110010, I will say yes, 1. Understand? If you call me 1100, so this is matching because this is matching with me. These names are matching. I'll say yes. But if you call me with a different name, 001101, and unfortunately, this one does not match with my name. So I will say 0. So for this, I'll say 0. For this, I'll say 1. Please understand. Let's say my name is Balaji. If you call me Ganesh, I'll say no, I'm not Ganesh, I'm Balaji. But this looks to be very simple. See, I'm telling you repeatedly, we have a habit of neglecting the simple things. But if you know this logic, if you know this very clearly, you will score very good marks in GATE. The entire digital papers, whether in college or in GATE, you should score 100%. You should score 100%. Think of it. If you score 100% in your digital paper alone, in your GATE exam, you're done, man. I don't know why you cannot score 100% in the GATE in digital paper. Same way, I'll tell you other one, analog and everything. That's the way you can able to easily get into good IITs. That's all very easy. I went through the same way. Please understand. I went through the same way into IIT. It is very easy to get into IITs, not difficult. Whether it's a JEE, whether it is a GATE, you have a wonderful mechanism to get in. And this also helps you in the job. You'll be very surprised in coming days how much this is going to help you. Now, let us take a very simple thing. You are a human being, you have a ears. Somebody called you Ram. Somebody called you Balaji. Somebody called Ananta Padmanabhan. Understand? Now, when I say Ram, it takes about 2 seconds. When I say Balaji, it takes about 3 seconds. When I take about Ananta Padmanabhan, It takes about 5 seconds. Am I right? Each one take different time. I don't want. I want all these things should take only 1 second. How could it possible? How do you make it? Very tough. No, what? I cannot. I cannot. You will not understand. If I say Ram in 1 second, you will not understand. If I say Balaji in 1 second, you will not understand. If I say Ananta Padmanabhan in 1 second, you will not understand. But our people, engineers, have found a way. That is what the trick here. What they have done is, if your name is 1011, how many bits are there? 4. They given a 4 inputs. Whereas human being is having only 1 ear. That means that 1 input. There's only 1 input. Because there's only 1 input, I have to call Ram 1 by 1. RAM, Ram. But in this case, what the engineers did was they have a 4 inputs and there's 1 output. Internally, what they have done is very beautiful. Okay, I'll make it slightly bigger one. Then I can able to draw it nicely. They put an AND gate. See here, it's a very simple logic. They put an AND gate and out. Done. Now, I have all the inputs here. I know one information. What information? If I AND gate, if all of them are 1, the output is going to be 1. This I know. This is the only information I know. But what I am giving here is 1011. Please understand. Normally, this is MSB. This is LSB, least significant. And this is MSB. This is LSB. This is the way we use it. This is the convention we follow. Everybody follow that. So reason to do that. Now what happens? If I connect all of them, what will happen? Since this is 0, this becomes 0, this becomes 0. No, I don't want. I want to make this as a 1. What I do here is, I do the inverter here. Wherever 0, I get the inverter here. Now, see this logic. See this logic. Erase this. There are 4 wires. So input can be from 000 to 111. 001, 0010, 010, 11, 0100, 0101, 0110, 0111. And same way, 1000, 1001, 1010, 1011, 1100, 1101, 1110, 1111. There are about 4. This is 4, 4, 4, 16 combination. Because 2 power 4. 2 power 4 is 16 combination. Please watch the number system videos in the folder. It's very important. You understand now. Now, out of this many combination, I'm a 1011. See, 1011 this. This is what the combination. I have drawn this logic for this combination. If you give any other combination, the output becomes 0. See that? If you give any other combination, the output becomes 0s. You give any input except this. If you give 1 1 1 1 1, 1 1, fine, 1 1, this is not gate, it becomes 0. So output becomes 0. You give any other combination except this combination, the output becomes 0. No, this don't get confused. You are getting some new, you are going very high level. I'm not. I am discussing nothing called. This is called combinational logic. Nothing more than that. This is not decoder or multiplex or anything. Don't get confused. That's a problem. That's not your problem. You people know so many terminologies, getting confused. This is trying to think very simple. This is nothing. Let us assume that. Let us assume that. How simple this thing is, you will be very surprised. I have a block. I have a block whose name is 1011000011. Understand? What is a block? How do you draw the combinational logic for this? You know one thing? It is very simple. It is very simple. Draw a AND gate. Simple. Draw a AND gate. And there is output. There's a Y. Done. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw 9 inputs. 4, 5, 6, 7, 8, 9 inputs. Understand? Now you have drawn 9 inputs. And here also draw outside 9 inputs. Simple. Done it. See, it may look very simple. I'm telling you once again, it may look very simple. I will bet when you are going to be exactly we are going to use it, you are going to forget it. I'll bet. We have a concept of forgetting very important things at the critical time. We studied Ohm's law in the college. We don't know what is Ohm's law. We don't know how to apply Ohm's law. That's a trick. I can give us some. If you know Ohm's law, V is equal to IR and P is equal to VI. Take the test which I have given. I know that you don't know Ohm's law. I can bet. That's your problem. So we don't know how to apply things. We always complicate things. Whereas in the industry, we make things simple. It's a big difference between you and us. You make everything complicated. Industry makes everything simple, because industry, the one thing is industry want output. Industry want your product to be marketed. If you start confusing, you will never make a product. That's why industry want product, everything to be think simple. It's an industry concept. Please understand. Now, how easy it is. In the college, did you ever think about this? If you ask a question, your answer will be different. But here, very easy now. See here, draw this. 1, 0, 1. Start from bottom. That's the way convention we do that. Don't ask me. Other way also it will work. But everybody will follow this technique. This is a convention industry. This is called MSB. This is called LSB. MSB, LSB. Least significant, most significant. The left is most, right is least. Now, I have to connect them. How do I connect? 1, connect directly. 1, connect directly. Or 0. 0. 0. Now think of it here. The beauty here is, let's see the beauty. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 power 9 is 512 combinations. Out of 512 combination, this logic will work only on this combination. If you give any other combination, this will not work. You can surely say 100% this logic. This is what the advantage of digital. I can say that this will work only on this logic. Now you erase this. Nobody should know that how you drawn this. Finish now. Now you can say that if you give here 1, 1, 1, 1, 1. Oh, 1 becomes 0 here. This becomes 0. You give any combination, this will become 0. Do you agree this or not? So please understand this. This is, if you should be able to take only 1 minute. If you take more than 1 minute for solving this problem, then you have to change, you have to practice. If I say that my block name is 11010, 1, 2, 3, 4, 5 bits. Draw a 5 input AND gate. It takes about 10 seconds. Then I draw about 5 inputs, another 10 seconds. I take 5 output inputs. It takes another 10 seconds. 1, 1, 0, 1, 0, another 10 seconds. Then I draw the 0 to 1, 0, 1, 1. Done. Output. Exactly 1 minute. Think of it. You could complete this in 1 minute. You understand this problem? Is it clear? If you have any doubt here, that means that if I draw the block with a name, you should take a minute, and if I give an input, you should know that at least now. If I give 1 0 0 1 0, the output become 1. That you should know. And I will give you one more very critical information. We have if I ask you that in our system, decimal system, if I ask you which is the smallest 5-digit number, very simple question. If you ask you which is the smallest digit number, we will say very simple, 10,000. Is the smallest 5-digit number. But if I ask you which is the smallest 5-bit number, this is the smallest 5-bit number, what you will say? You know, think what is this? 0 0 0. In decimal, all the 0 prefix, okay, we don't consider. But in binary, all the prefix 0 is also value. So if I say a 5-bit number, it starts from 0 0 0, not from 1 0 0 0 0. This is wrong. Only this is right. Please understand that. This is a very, very important information for you. Is it clear? So now I have a block. I have a block which has a name, and I have 4 inputs. I draw a gate. I say 1 0 1 1. That's it. Now I'm asking you, I've used now AND gate. Somebody asked me what is the use of AND gate, and somebody asked you what is a NOT gate. Now I'm using them to create a block which, if I give an input, only when that input comes, output comes. Now I'll explain to you later how this is getting used. You know one thing, who is going to control the input of the blocks? Your software. Software is going to give the input. The output is going to control the hardware. Please understand, please, how it is. The moment you realize that, you win the game. Then you will understand whether it's ARM, whether it's a RISC-V, whatever it is. Every processor you will understand very easily. Whether it's Intel or AMD or NVIDIA or whatever, everything will be understood. Whole computer architecture is under you, if you understand this. There are only 3 logics. There are only 3 logics. One is called, first logic is combinational logic. Second logic is sequential logic. Third logic is tri-state logic. Understood? So, transistor, a switch, and AND gate, OR gate, NOT gate. And from there, we create 3 logics: combinational logic, sequential logic, and tri-state logic. From there, we build. This is called building blocks. You may call this as a sand, a brick, and a room, like that, wall and room. That's the way it goes. When finally, the end of it is a microprocessor. That's the last one. Starting with a switch, transistor, and the end is microprocessor. That's a, you should know the flow. Somebody asked me the flow. That's the flow. Now, there is one more small requirement in the industry. That is very tricky. If there is a block, the block is having 2 names. The block is having 2 names. The block is having 2 names, 1011 and 0101. Let's say somebody called me Balaji, somebody called me Bala. There are 2 names I have. Same way, this block is having two names. That means that if you call 1011, I should say yes. If you call me 0101, I should say yes. But I've already discussed, if you design for this, if you put an AND gate, if you design for this 1011, you have designed for 1011. If you give 0101, what will happen? 0. So this is 0. So no, for you, you have to get this also 1, this also 1. How do I design that? So engineers did a very good thing. That's the beauty here. What they have done, the engineers, is they made two blocks. They made two blocks. They made two blocks. 1 and 2 blocks. This block name will give you 1011. This block name will give 0101. I take 4 inputs. Am I right? And now what we do here is we connect all the 4 inputs. Am I right? Then we did the same thing here. So we are given a joint here and connected. So if we call here 1010, it goes to this guy also 1010. It goes here also. Say 1011. It goes here also, here also. If we give, same way, if we give 0101, it goes to both. Now what I have done here is, in this block, the first block, I have a logic. I have a logic which is for 1011. 1011. This block is 0101. Zero one. Zero one. Am I right? Now what we are, but we need only one output. So what we have done here is we have used the OR gate. Now understand this logic. Now you see here, if we give 1011, this become 1 because this name is matching with this guy. So this become 1, this becomes 0. I get 10. The output is 1. If we give here input as a 0101, then this one is matching this guy. Okay. Then when it's matching this guy, this become 1. This becomes 0 because this is not matching. So it becomes 0 and 1. This become 1. Understand now? Is it clear? So if I have a 2 names, still I can do that. Why 2? If I have a 3 names, I may be having one more block. Let's say I have 111. Now I take this also and give it to the input. Again, doesn't matter how many inputs you have. So understand this. Also, yeah, that I'll give you the next session. That is on Friday. We are going to discuss about application of combinational logic. That I'll explain to them. Okay. I've not discussed about the application now. Right now you understand that I have a block with one name. Then I have it, I control it here. 0, 0, 1, 0. That is first one. Very easy. 0. It's very simple. Next
Sir?
one is, yeah.
Sir, just a small doubt, sir. Sorry for the interruption.
No
Sir,
problem.
you have connected inverter internally, right? Internally, internal black box. Inside the black box, you have
Correct.
mentioned
Yes.
inverter. Sir,
Correct.
outside we can't mention, right? Outside black box, we can't.
No. We don't want to confuse it outside. See, from what is the input to the black box is 4 wires. This is
Okay,
what
sir.
a block. People always use the black box for a function.
Only inside we are using.
Yeah, inside we are using every when we draw a black box, you have to draw the circuit inside, not outside. When somebody draw the black box, you should draw the circuit inside, not outside. Understand?
Okay.
All your circuits have to come within the black box. Now think of it. I have a multiple input. One output, but one combination. There's a first one. There's a very simple one. I have a multiple inputs. I have one output. We draw the gate. We connect them, whatever it is you wanted. We connected based on this case 1100. We connected. Am I right? This is the first case. The second case is multiple input, multiple output, multiple combination. Now the black box has a multiple combinations. I have 101 and 1010, 0100. That means that I have multiple inputs. I have multiple boxes, black box. This gate name is 1010, 0100. These 4 are connected here. The output be connected through OR gate. And it can be anything, not only one, it can be anything, doesn't matter. Now, third one is very tricky. I have multiple input, multiple output. How many inputs? Multiple input, multiple output, but multiple combination. Now also we do very simple. Now don't get confused. I have 4 inputs. I have 2 outputs, assuming. Now you have to draw like this. There are 2 blocks. This 4 inputs goes here, 4 here, goes out. I divide them. See how I do that. See, I start from here. See that. I have a block. Which has 2 outputs and 4 inputs. Since I have 2 outputs, I make them 2 blocks. And I connect them. And this also goes. All are connected to both the blocks. Now, I take this alone separately. One output and multiple inputs. Other one is separate. And this guy may be n number of combination. 1011, 1100. This guy could be 000, 0010, whatever it is. Then make them into 2 blocks. And make use of OR gate. Am I right? Now you take this block 1011, 1, 4 input 1, 0, 1, 1, and do that. Simple. So ultimately, this is what the important, but we are dividing a big problem to 2 small problems and 2 what do you call medium problem, 2 medium problem, and then we split into simple problem. Simple, medium, big, or small, medium, big. This is called divide and conquer. Please understand. So understand, that is this what I have explained now. I will use it on the combinational logic, then you will understand. Okay. Then we will discuss more on this. But we are not going to use this much. That's why I'm not going more than that. But I'll give you some more inputs now. That actually understood. You saw that now. You saw that here 1 0 1 1 0 0 1. I have to draw how many wires now? 8 wires. We don't like that. We always draw only one wire. We don't like to draw so many wires. We draw only one wire. We put a one wire, put a slash and 7. This means that this is a group of 7 wires. This is a group of how many wires? 7 wires. We bundled them to one wire. This is called, the group of wires, bundle of wires is called bus. Okay, called bus. So let me tell you how it is works. If you have a group of signal, I call this as a A. Only one name, but it's have 8 wires. How many signals? 8 wires. You know what is this meaning actually? This, we expand it like this. A. So 8 wires. Because we have drawn 8. Now everything starts with A. Because the name is A. Prefix is A. Add 0, 1, 2, 3, 4, 5, 6, 7. So it starts from 0. Start from 0, end with 7. If we put here, for example, if we draw here a block which has a wire, and I draw it this as a 16, and I call this as a D. Then we expand this to like this. We expand this to like this. With how many wires? 16 wires. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then we write them as a D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, D15. Understand now? So this also is a nice way of representing the bus. So if I do like this, if I say that A is the block, that's it. If I draw like this, what happens is internally you draw a gate, and 6 inputs. Now take this guy and 1. This is MSB 1, 0, 1, 1, 0, 1. Understand that we do not make things big. Also, there's one more important thing. Suppose, let's say I have a 16-bit is there. Suppose I have a block. Now this guy is having 16 input. How many input? 16 input. Then the name is going to be 1 0 1 1 0 0 0 1 1. It's a boring. So we write them in a short form. 6 8 E 3. We write them in hexadecimal. Not in decimal. Now 6 means, you know what is this here? 6 means 0 1 1 0. That is 6. 1 2 4 8. 8 1 0 0 0. 1 2 4 8. E 1 1 1 0. 1 2 4 8. 8 plus 4 12 plus 2 14. 14 means E. 3 means 0 0 0 0 1 1. You understand now? Instead of writing 16-bit, we write here. But this and this has to match. If you give a 16, if you give 12, that is not right. You have to give here, these two have to be match. Understand now? If we say here 32, oh, drawing 32 is big, man. So what we do here is we write very simple. F, 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 F. That means that all are 1, 1, 1, 1, 1. How many ones? 32 ones. One, two, three, 4, 5, 6, 7, 8, 32 ones. That means that if all the 32 wires, if a 1 comes, then the output become 1. See, these are all very important for you because you're going to deal with ARM microcontroller, which are all 32-bit. The market even 64-bit has come. Okay, that is next. Okay, so yeah, F means 4 ones. That is 1, 2, 4, 8. That is in hexadecimal. 0 to 9 is same. 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. When I say all 1, 1, 2, 4, 8. 1, 1, 1 means 8 plus 4, 12. 12 plus 4, 14 plus 1 is 15. That is what this. So 32 input, 32 ones and 8 Fs. No, how you should know how to view the circuit diagrams. These are all the technique circuit diagram. When I draw here a block 75, 8. I have another block 126, 12. If you draw like that, you should understand, oh, I've connected here. This guy is A, 12. This is connected 8. So A0 to A7. This connected to 12. A0 to A11. You understand that? Okay. So these are the way how we do things simple. So please understand the combinational logic is a very, very simple one. Whatever you forget, I don't mind in the class. But don't forget this. I have a block which has a name as 10110, which means 5 inputs. 10110. That means that 1 is tight and 0 is gate. 110. And Y. Am I right? Is it clear? This you should never forget. Yeah, but right now I'm written a binary. I've written a binary. Okay, I don't want to write it as a decimal. I'm giving a thing binary now. Okay, then you can draw the things as a second one is you draw 1010 11001 as 8 wires. Now you draw it 8 simple one. Oh, previous not 20 wires. That's Shuma, I just showed you. And so right now I'm discussing about binary. I'm not doing hexadecimal. Then what we did was we simplified this. Instead of writing like this, we made this as a 8. We made this as a D, 8D. So we made a 8D. So understand now. So, and also we discussed that a combinational block with one name, only one name. Then we discussed 2 names. 2 names. And then we discussed multiple outputs. Try it out. Don't there's nothing confused, but I'll give a video to you this. Okay. Then try to look at the number system one. Then you will try to understand that. And don't go in depth. One output is sufficient. Even multiple inputs are not required actually. This all I told you because of combinational logic. Actually, you should remember. I don't mind whatever you remember. One number, one output, one combination, multiple inputs. This is very important. All the other things are not important. Anyhow, we are going to discuss about combinational logic application on the next session. That is on Friday. Okay, that time you will be able to understand that. Okay. If you have any doubt, you can ask me now. But don't think something great is there. This is what combinational logic. This is what combinational logic. It's as simple as this. If you think something more, see, please forget one important thing. If you use anywhere K-map, industry useless. Industry don't want K-map. Please forget about K-map. You lost the interest on digital. You lost the interest on everything, on the combinational logic, everything, because of K-map. Nobody understand why K-map, and they wanted you to use the K-map, and finally lost your it's a very simple one, digital. But you lost the interest on the digital because of K-map. I know that. I did a lot of talk to people. Don't use K-map. We don't need K-map at all. We never used it. If you forget the K-map, I'm very, very happy. Okay, then let me stop the recording.